I'm Ben Albrand. I'm a senior research scientist working at UV Labs. I'm here presenting zero-shot multimodal artist-controlled retrieval and exploration of 3D object sets. This work arose out of a collaboration between Unity Technologies and the Feature Valley Lab at North University. What's our motivation? So 3D content creation is a high barrier to entry and requires specialized skills to design and generate these meshes or as renderable representations by hand. For building libraries of assets for the layout design is a common workflow for how to navigate these large data asset dumps once we have them. Or how can we enable higher-order descriptive retrieval of large-scale data sets? We construct a database of latent embeddings from a pre-trained model, CLIP, offline, and use that to perform lookups in an interactive and semantically aligned way at runtime. We will discuss the background of CLIP, our approach for leveraging CLIP with 3D mesh retrievals, and show real-time demos of our retrieval results. We will discuss and demonstrate zero-shot weighted multimodal retrieval to expose artistic control to users, as opposed to typical approaches that tend to be these one-to-one black boxes where you don't have any control over the final output. For the background, we will discuss the dataset construction and how we use clip latent encodings to construct this dataset. So, we take ShapeNet, and then for every mesh in ShapeNet, we render it 3 times. From the front, from the side, and then a canonical perspective view. And then we feed that into CLIP and generate these latent vectors for later retrieval. So what is CLIP? So we're making use of these pre-trained weights from OpenAI's CLIP model, and everything we do in this paper is zero shot on top of that existing model. What CLIP allows us to do is to invite artists to provide input prompts and reference images to be part of the retrieval process. If we also add weighted fusions to these prompts to allow more artistic control over the retrieval results. We'll revisit this. So what is CLIP? Put briefly, it's a way of projecting text and images into a shared latent space and semantically aligned. That is to say, if we input a picture of a dog and a text, a big red dog, one might expect to find Clifford, if it's present in the retrieval dataset. So once we have this dataset of renderings, it's the ShapeNet categories from these series of views. How do we perform the lookup? In order to make use of this constructed dataset of CLIP latent codes, first we fuse the latent encodings together according to the user-provided weights. We perform lookups by a cosine similarity scoring between the fused latent codes and the dataset in order to pick the top K matching results for output. So what do we mean when we say weighted multi-modality fusion? It means that we're taking the weights of each of these inputs and multiplying the latent code by these weights in order to fine-tune output results. So here we see on the left that a sketch of a table is given with weight 0.1. And then we sketch some swirly things on the right, and we say, we think that that's more important, so we're going to weight it at 0.9. So since this data set contains cars and chairs and tables and airplanes, you can see that the chairs and the tables are entangled somewhat. So in order to fine-tune these results, we add the text a table to retrieve a table with only these features on the legs. And so on the left, we show that combining images or photographs of airplanes with detail images and the weighted multimodality fusion allows you to find highly specific results. And so to summarize, the fusion is just summing up all of the latent codes that are multiplied by their respective weights. We'll now show several real-time demos demonstrating the retrieval system that we built. In conclusion, weighted multimodalities are a powerful way to explore the latent space of these models. We show how robust it is with respect to inputs with no additional training. These concepts can also be applied to their generative model counterparts, bearing in mind that you've considered the latent distortions that you've introduced. There's a bit of an ImageNet moment happening with CLIP and these contrastive models that are enabling many exciting downstream tasks to be explored. Thank you for your time.